All right, for the trig functions and applications test here, so we need to sketch one full cycle and then list some of the key properties. So my advice on ones like this one, first off, they tell us to use radians. So let's get the x scale set up. I'm going to look at that value of b, the pi over 8 here, and we're going to use that to set up the scale and get the period and everything. So b is pi over 8. We know that the period is always the standard period divided by b. So in radians, it'll be 2 pi over 8. And to divide by that fraction, we will multiply by the reciprocal. So I'm going to multiply by 8 over pi. And in this case, throw a 1 under there. So the pi's do cancel, so we just have 2 times 8. So the period should actually be 16. Okay, so when we set up our x scale, make sure that last one, the fourth one, is the period. That's when it'll go through its entire cycle. And one of the biggest things I see on these problems missed is people do not label the scale properly, and then it's not clear where the mins and maxes are happening as far as x values. So make sure that's labeled. And then we know it's 4 equal pieces to equal 16. So we're going to have the 16 divided by 4 for each one. So 4, then 8, then 12. Okay, and the period, like we said, is 16. So that is set up. Other than that, let's see, we do have an amplitude of 2. And we're going to end up having a midline of whatever the vertical shift is going to be y equals 1. Okay, so however we want to graph this, I would suggest maybe graphing before the shift, and then we'll move everything up 1. So the parent function for sine is the one that will start at 0. Again, I'm doing this before the shift. And it's going to go up to its maximum. Now in this case, the maximum is going to be 2. Back to the midline, down to the minimum, and then back up. Okay, so this would be before we shifted everything up 1 unit. Oops, but that shows one nice full cycle. And then our final step will just be to vertically shift everything 1 unit up because of that plus 1 out there. So we'll start at 1, we'll go up to 3, come back down to 1, go down to -1, and then back to +1 for a final graph, going through those points. And we show the arrows, show it keeps going. And that would be that one. All right, next problem we have this one. Since that plus 30 is with the degree symbol, we're going to use degrees to set everything up. So let's get some properties and get the graph going. So first off, amplitude, of course, is 2. And now the coordinates of a minimum, I'm going to save that. Let's graph this thing first, and then we'll figure where the minimum is. But again, I'm going to set up the period and set up the x scale. We do have a b value of 3 here. So since this one is about degrees because of that 30 degrees, we're going to take 360 instead of 2 pi and divide by 3 because that's the b value to get a period of 120. Okay, so again, the fourth one has to be labeled 120, and each one is an equal piece, so 4 equal pieces, so each one is going to be 30 degrees, 30, 60, and 90. Okay, and then for this one, we can graph the cosine curve, and then we'll worry about this one actually has 2 shifts, horizontal shift and a vertical shift. So let's first just do the 2 cosine graph. It would start out at its maximum of 2. And cosines are the ones that go down, down, up, up. Okay, so that would be the curve before either of the shifts. But it's going to help us see where to move things. So if we just think about now, we really need to take each point to the left 30 degrees and up 1 unit. So for this scale, left 30 degrees is just 1 box to the left and up 1. So we'll take each point, that point right there, left 1, up 1. Okay, the point at 30 will go left 1, up 1. The point down here at 60 degrees, left 1, up 1. One at 90 degrees, left 1 and up 1. And the 120 would go left 1 and up 1. So this graph's going to do something like this. Again, with the endpoints going back down. And that makes us able to see where the minimum is occurring right there. So the coordinates there would be at 30 degrees, for the x and a -1 for the y value. And that's why it's so important to label those x values so we know where that stuff happens. Okay. All right, then we have the application word problem, bungee jumper, right? Jumping off 85-foot high platform, and the graph shows his height, or the height, x seconds after jumping. So we need to find the period, the midline, amplitude, equation, all that stuff. So it looks like for our purposes, we're going to need max and min. So the max, they kind of told us, was 85 feet. We can see on the graph, 85 feet. It looks like the minimum, he gets pretty close to the ground there, down to 5 feet. And we can use that stuff to help us find the period, midline, and amplitude. Okay, so first off though, period. So we need to show how long it takes to do one full cycle. So with this graph, if we're starting out at the top and then kind of coming back down, it's not perfect, but it's going to come back up and get back to its maximum right there, which actually has an x value of 9. Okay, so that would be the period. This one's in seconds. So 9 seconds would be the period. It's not 11. I know there's a couple other points out there, but it gets back to starting over at 9 seconds. Okay, so now we can find midline and amplitude and then try and write the equation. Okay, so midline is always going to be the average of the max and mins. Okay, so the 85 plus 5 over 2, we just want to find the exact center. So 90 over 2 gives me a midline of y equals 45. Okay, so that should be kind of right through there. Okay, make sure we do put the y equals. It is an equation of a line. And then amplitude. So amplitude is going to measure height from the midline, okay, or half the total height. So we can always do max minus min to get the total height. Divide that by 2 to get half the height. So 80 over 2 gives me an amplitude of 40. Okay, now we should be able to piece all that stuff together and hopefully find an equation to model the height here. So what I'm thinking, this one starting out at its maximum, that's what cosine curves do. So this is going to be a cosine graph. Okay, and we have an amplitude of 40, cosine of something. Now the period was 9, so the b value in the equation needs to be 2 pi over that. And then we need our x in there. And then to get the midline shifted up 45, we need to have that vertical shift of a plus 45 at the end. And that should get us the equation. All right.